Okay, 3.2, evaluate and graph logarithms. We're going to convert between logarithmic and exponential form and describe transformations of logarithmic functions. That's what we're going to be doing in this section. Okay, so f of x equals a to the x. That's an exponential function. It passes both the vertical and horizontal line test. Yes? So that means it has an inverse function as well. That means its inverse is also a function, and that inverse is a logarithmic function base a. So, remember to turn on my pen. Okay, we have y equals log base a of x if and only if a equals a to the y. You guys remember going back and forth between these last year? Now, the top just says that x can't equal 0, that a can't equal 0. Bases can't be 0, can they? It doesn't work. And we say it log base a of x. I don't want log ax. That's not a thing. It's log base a of x. So, when we do this, we need to look at it. If you notice, the base of the logarithm is also the base of the exponent. Yes?
Yes.
Yeah. Okay? And the domain and range interchange places because they are inverses of each other.
Yeah.
We have here, actually, it's the whole thing. This, let me just, you notice that the x is in the logarithmic function on a logarithmic, but in the answer on the exponential, yes? So domain and range interchanging places. That's what inverses do. Guys ready?
Yeah. Wait, Evan, you're ready? You wrote that down?
You sure?
Yeah.
Okay. There's a lot there, but you don't need a lot of it, do you? Okay, so since exponential and logarithmic functions are inverses, that domain and range interchange places. So I wrote it in a very clean form. I have y equals log base a of x. That's logarithmic form. And x equals a to the y is exponential. The base of the logarithm becomes the base of the exponent, correct? Okay? And the of becomes the equals, and the equals becomes the exponent. So I have two there. I have one in logarithmic form and one in exponential form. I would like you to try to switch forms. See if you can dig that out of your archives from last year and accomplish it.
I deleted it.
Well, let's just try. You got it right in front of you.
My files have.
Plug and play, right? Try it. Go from logarithmic to exponential, exponential to logarithmic. Write really light if you think you're not going to do it right.
Wait, I'm confused. What are we doing?
You're trying to go from exponential to logarithmic, and then, I'm sorry, logarithmic to exponential on the left and exponential to logarithmic on the right, using the pattern up top. You're just giving it a shot in the dark. See if you can place things where they go.
That's. Do you want us to, like, if it's a square, do you want us to do the square or you just leave it how
I don't want you to solve or anything. I just want you to,
it is? Put it in the right place.
yep, I want you to put things in the right place. Who would like to take a stab from logarithmic to exponential? Garrett?
Just
would be 3 squared.
So it'd be 3 squared equals what? 9. Does 3 squared equal 9?
Yeah.
Yes. Okay. How did you figure that out, Garrett?
Well, exponential form is a to the power of y, and a on the log is 3, and then y is 2.
Right. So you just put them in the places that you saw on the form, right? The base of the logarithm becomes the base of the exponent. That will always be. Okay? The equals becomes the exponent, and the of becomes equals. Okay, who wants to take a stab at 5 to the third?
I got it.
Ethan.
3 equals log base 5 of 125.
So 3 equals log base 5 of 125. So could you put log base 5 of 125 equals 3?
Yeah.
Yes. Okay, so how did you figure that out, Ethan? Because you're right.
The A is 5, the Y is 3, and of 125.
Correct. So the base is 5. And my exponent is 3, so that becomes my equals, and it's the of 125. Now, I typically do this, so I know exactly what I'm taking the log of, but your book does not. If you struggle with that, I would suggest putting parentheses around what you're taking the log of, because we will have H's and K's accompanying us with this, correct? We will be moving this graph left, right, up, down, reflecting it, just like we've done in the past. Questions? How'd we do with that? How'd you do with it? Good? Did everyone do okay with it? Okay, so it wasn't deleted. It was maybe back there a little further. But do we just place the things where they go? Yeah. Okay, so when evaluating logarithms, remember that a logarithm is the inverse of the exponential function. So when somebody comes up to me and they say, I'm stuck, the first thing I'm going to say is what?
Switch form.
Switch forms. Exponential into what? Logarithmic into exponential. So we just did a couple of these, but I want you to switch them all 3. See how quick we can do it correctly.
What square is 8?
Figure it out.
Okay, so on the first one we have 3 squared is 9, is that correct?
Yeah.
And on the last one we have log base 5 of 125 equals 3.
3.
Okay,
Yeah.
and on this one I'm going to make this just be y. Yes?
What I did.
So you should have 2 to the y equals what?
8.
8? Okay, so what do I have to do to solve this?
Solve for y.
Solve for y. How?
You do it in your head.
No.
Well, the x equal to 0.
What did we
No,
do?
that's the answer.
Put x equal to 0.
Say that again. It's 2 to the third because we just got done with exponential rules saying if the bases were the same, what's the same? The exponents, right? So y equals 3. So you have to remember your exponent rules because logs and exponents are inverses of each other. Are the rules going to help you solve one of them? Yes. So if I can use that 1-to-1 property, the bases are equal, the exponents are equal, my life is much easier. Am I good?
You're great.
Thanks. Okay, use the definition of logarithmic functions to evaluate. So this says f of x equals log base 2 of x, and x is 32. So how do I do this?
Like we just did.
I plug what in?
32 into
32
x.
for x. Wow.
Guys, every time it jumps, it just means I didn't hit the pin, right?
We know that.
So I put that in for x. So I have y equals log base 2 of 32. And the reason why we put things in parentheses when we plug them in, because of means multiply, yes? So parentheses. So what do I do now?
Switch forms.
Switch forms. So what's my base?
I can't think of this, okay.
Base 32.
2.
Nope. 2 to the
2 to the
y equals,
32.
so 2 to the what power?
Fifth.
So y equals
5.
5. Choose the base. So y equals log base 3 of what?
1.
1. How'd you get 1?
Because it says to plug x in for,
Right.
1 in for x.
We put 1 in for x. So it'd be 3 to the y equals 1.
1/3.
What exponent gives you 1 every single time?
0.
0. So 3 to the y equals 3 to the 0. Because anything to the 0 power is what? 1. It's not 0. It can't be 0. You'd never have any other exponents. So y equals what? 0.
Why wouldn't it be 1/3 though?
That would be like if I was doing negative, like if I had 3 to the negative 1 would be 1/3. Okay, try the next two on your own. Who wants to take a stab at C?
Stab.
Isaiah?
So whenever you do everything, it would be 4y, 4 to the y equals 2.
Okay.
To get to the 2, you would have to take it to the negative 2 to get to 2.
Negative 2 would give you 1 over 16. Natalie,
Could,
you're on the, you're,
so you
thinking.
have the 4y equals 2, could you make that 2 to the 2y equals 2
Yes.
to the first?
because 2 to the second is 4, correct? And 2 to the first. Did anybody say that 2 was 4 to the 1/2?
Yes.
I was thinking about that.
Okay, because 4 to the 1/2 is 2, yes?
Yeah.
But
I
either
think
way,
that's
we're
what
going to
I
get
was
2y equals 1 and y equals what? 1/2. So either of those two methods works, correct?
Yeah.
If you can see that 2 is 4 to the 1/2, then it saves yourself from dividing by 2. That's about it, right? Okay, good job. Okay, D. Okay, let's go.
Okay. It's 10. Is it not built first?
It's what?
Is it to the first?
What?
Oh, never mind. I don't want to do this anymore.
Brad?
Okay, so you get 10 to the y equals 1, or equals negative, or equals 1/100.
Mm-hmm.
Then you would change it, so I changed it to 10y equals 100 to the negative power, and then changed it to 10y equals 10 to the negative 1 power.
What about negative 2?
Yeah.
That's what he said.
That you were, yes.
Yes.
Okay. Why did I have to do the negative exponent?
To
To
make
get
it
Because it's reciprocated.
To get the 10 from the denominator to the numerator, right? And the 100 is 10 squared. And so it's negative 2. So what's y equal? Negative 2.
Okay, so this one would have been where I used.
Yes, this is the one where you were to use the negative.
Well, I did. I just had the wrong negative.
Questions? This, once we switch forms, is it exactly what we did last week?
Yeah.
Yes. If you did it last week, yes. Okay, so the logarithmic function with base 10 is called the common logarithmic function. It is on our calculator. It is right here next to the 7. It says log. If you notice, you probably can't see there in blue, it says 10 to the x. Well, 10 to the x is an exponential function, yes? And log with no base written is what, base 10?
Yeah.
So it has the inverses on one button. It does that with all the buttons. The inverses are the second. So is on there. And the common log again is base 10. Does anybody remember why our common log is base 10?
That's just how it is in the calculator.
Universal.
It's universal. What is our number system based off of, guys? 10. Our number system is based off 10. They do have mod. I took a class a couple years ago where we did mod 7 and mod 5. So you counted and your base was 5. Your number system was based off of 5. So it's a little different. But it's universally our number system is based on 10. So therefore, the common log is base 10. When we have base 10, do we write base 10? No. When there's no log base written, what is your assumption? It is what? Base 10. So don't come up to me and say,
This doesn't have a.
Mrs. Mick, this doesn't have a base. Because it does. What's the base? 10.
Twice.
Okay, so here are our rules. Log base A of 1 is 0. Always will be 0. We just saw that on the other slide. Didn't we have to get 1?
Yeah.
And the only exponent that gives you 1 is what? 0. So they have the logarithmic form on the left and the rationale on the right. Okay. So log base A of A is 1. Because A to the first is A. If the bases are equal, it's 1. Now, I tend to even forget about number 2 because number 3 takes the place of number 2. If you look at number 2, my power is what on number 2?
1.
1. Because there is no power, yes?
Yeah.
But if you look at number 3, it just says when the bases are equal, the answer is the what? The exponent.
Oh, yeah.
Okay, what was the exponent on number 2? 1. So when we're in the grand scheme of things, you want to remember 4 things or 3 things.
I remember all of them.
You would remember all of them great. I would go, if I had to remember, I would be going for 1, 3, and 4. 3 is called the inverse property just because if you write it from one form to the other. Tell me when you have them all written down, and I want you guys to just look at 3 and 4 for a minute without writing so you can notice a few things.
For the exponential function
On 3?
would be, yeah.
It's a to the log base A of x equals x. This whole thing right here is an exponent.
So let me guess, on number 4, if the bases are the same, x equals y.
Yes. That's the 1-to-1 property to me. I always just call them the duh property because I'm like, duh, right? If everything on the left is equal to everything on the right, doesn't x have to equal y? Yeah. It's one of those that we always forget, though. Okay, does everyone have 3, all of them written so we can talk about them real quick?
I have all of them written.
Okay, so let's look up here, please. If you notice on the left of number 3, it's the inverse property, and I'm never gonna say, when I say what property, I'm never gonna say 2, it's always gonna be 3. Again, 2 and 3 are exactly the same. Except 3 is for any exponent and 2 is only for what exponent? 1. Okay, so when I look at these, my bases are equal, right? The base of the logarithm and the base of the exponent on the left. They're equal, correct? So the answer is the exponent. If I look on the right, the exponent comes first, but is the base of the exponent and the base of the logarithm still the same?
Yeah.
Yeah, they're still the same. So the answer there is the of, just because it's in a different form. Now, I tend not to do the right-hand version very often, but it does work. It drives me nuts. I will take the log of both sides of the function, but I have a really hard time raising it to a power because then you get really funky exponents. I just go ahead and just change the forms is what I do. So 1-to-1 property again, log base A of x equals log base A of y, so x has to equal what? Y. We're going to use these to do some problems. So, it says simplify. Log base 4 of 1. We could set it equal to y and do all this stuff changing forms, but don't we have a rule that tells us what, Kale?
0.
What
That's
rule
what it
tells me
says.
it's 0?
1.
1. 0 by property 1. There's no other work. Now I could go 4 to the y equals 1 and 4 to the y equals 4 to the 0 and y equals 0. But why would I do that?
There's already a property that says
There's already a property. Because what we're doing here, what we're answering here is what power of 4 gives you 1? Well, what power of 4 gives you 1? 0. 0. Okay, so on B, log base square root of 7 of the square root of 7, and this is where I would really put x parentheses, is what?
Number
1.
Number
Yeah, you're right. It's property number what?
2.
Or
2.
3.
3. Property number 2 or property number 3 tells you it's the exponent, which is 1. So it is what? 1. When you have those problems, guys, try to use the properties. Try to remember them. I expect you to remember all on the test, so dig them out of the archives. Could I have gone square root of 7 to the y equals square root of 7? Well, what's the exponent on the right? 1, so y equals what? 1. I could have done that, but why would I when I know that when the bases are equal, the answer is the exponent, correct? So, 6 to the log base 6 of 20. What? Property 3? And the answer is 20.
Can you go through that one?
Yep. Because this would be log base 6 of y equals log base 6 of 20. Then we would go to property 4, right? Because the bases are equal, what has to be equal?
X and Y.
X and Y. No, well, yeah. So y equals 20.
I mean, that works. Yeah.
When you were working on them today, if you can name the property, will it help you remember what you're doing? Yes. And I just prop number 4, prop number 2, or you could put P1, P2, P3, P4. I would probably not expect a lot of 2s because just 3 cover everything.
Yep.
Yes. Okay, 3 covers 2, so why remember an extra one?
I'm only going to put number 2.
Well, a number 2 doesn't work for everything because number 2 applies only to what exponent? 1. So you would be incorrect if you only put it.
Okay.
Okay, so we need to remember their inverses of each other, yes? So we're going to sketch an exponential graph, and I hit it before I did it. Okay, so I'm going to sketch an exponential graph. What do we remember about exponential graphs? Where does it go through?
The 0, 1.
0, 1, so it goes through right here, yes? Looks like that. Okay, so let's see. Domain,
All real numbers.
all real. Range,
Greater than 0.
greater than 0. 0, it is not included, right? There is a horizontal asymptote at where?
Y equals 0.
Y equals 0. What else? We got a y-intercept.
Or 0, 1.
Anything else we need to remember? It's increasing, but is it it's increasing. Right? We're good?
Yeah.
Okay. So if I can remember exponential, and I know that exponential and logarithmic are inverses, should I be able to get my logarithmic? Yes? Because inverses switch what two things?
X and Y.
X and Y, domain and range. Okay, so I'm going to make a graph again here. And I'm going to come down here, and I'm going to write domain, and I'm going to write range. And if it switches the domain and range, what should my domain be?
Greater than 0.
Greater than 0. And what should my range be?
All real numbers.
All real numbers. Just switched them, right? Well, I have a y-intercept at 0, 1, so when inverses, that point's going to switch to what?
1, 0.
1, 0. Well, that's not a y-intercept, that's a what?
X.
X-intercept. Just going to go through there, right? And it obviously is going to be increasing. Well, I can't have a horizontal asymptote. I'm going to have a what?
Vertical.
Vertical at where?
Y equals.
Not y.
X equals 0.
X equals 0. So my graph is going to do that. Did those two graphs, if I put them together, reflect across that nice
Yeah.
X equals Y line? Yes.
Probably.
So, if I can remember my exponential, can I automatically get my logarithmic? Yes. Now, is the same left, right, up, down going to apply? Yes. And in this case, we're not going to move on exponential, we moved 0, 1, but on logarithmic, we're going to move what? 1, 0, and our vertical asymptote, right? Am I good? Am I good now?
Can't read the bottom.
Yeah.
X-intercept
1.
1, 0. I need to put my number in when I got my computer. Evidently, it didn't. Good?
Yeah.
Okay, so if I sketch these two on the same, this is what they're going to look like, aren't they? I plugged in 2, because I can plug 2 really easily. Like I can plug into a base of 2, can't I? Yes?
Yeah.
And I could come up with points. And then all I have to do is when I come up with those points, I just have to interchange X and Y, don't I?
Yeah.
So do they reflect across the X equals Y line?
Yes.
Yes. Just make it a quick sketch, guys. You don't really need it. You just need to know that you can do it. I will tell you, I've never sketched a logarithmic graph first in this scenario. I've always done the exponential and just interchanged my X and Y.
Okay.
Am I good?
No.
Stretching.
other sticker on there.
I did.
No,
This,
that one's yours.
I don't know, Dustin.
And that one's not wasn't there.
Well, that one came from the adapter. The adapter for the new MacBook had sticker in it. I'm like, really?
Just start filling out full of stickers.
Yep. Ready? Natalie, you good?
Yeah.
I'm waiting on you. Okay, so describe the change.
Down one.
Down one. How'd you know the first one's down one?
Because it's not negative one.
It's not in the parentheses, right?
Yeah.
So it goes down one. So if it goes down one, did it change the domain?
Yeah. Wait, no.
No. Did it change the range?
Yes.
The range was all reals.
It changed the intercept.
Did it changed the intercept, right? So the intercept was 1, 0. So it's not going to be an intercept anymore.
-1.
It's going to be
Wait, it's 1.
1, -1. So it's not an x-intercept anymore, is it?
No.
No, but that's where that crook would be, isn't it? Was there anything else that would change? Is it gonna? If it didn't change the domain, is it gonna change the vertical asymptote?
No.
Nope. So everything else is the same. Okay. What about this one? On H,
Left
Left
three.
left 3 because this is opposite. So left 3. So if it moves it, let's see. So 1, 0. Going left 3, I got to subtract 3 from this, don't I? What am I going to get? -2, 0. Is it still an x-intercept? Okay, so it's still an x-intercept. But if it moved my x back, my domain was 0 to positive infinity, correct?
Wait, where'd you get the -2, 0?
I took 3, because it went back 3, so that would be x, so I took 3 from the x.
So how would it be negative
Huh.
2 to positive infinity?
What? Say it again.
Negative 2 to positive infinity?
Not 2. Subtract 3 again.
Oh,
0 minus.
So it'd be 0 minus 3 would be
negative 3.
-3 to positive infinity. And these are all parentheses because -3 is an asymptote, isn't it?
Yeah.
Now, where am I getting this -3 at?
From the.
Up there.
Up here, I went left. Okay. Does it change the range?
No.
No, the range was all reals. Nothing really can change the range, can it? It changed the x-intercept. Right, unless it's an application problem, you're correct. Okay, the x-intercept changed, and so is domain going to change if the x-intercept changes? Like if this moves back or forward? Yes. Anything else change? No? Okay. What about this one? First of all, is it written in order?
No.
No. Okay, so we need to write it in order.
Should be.
So log base 3 of -x plus 3. Now the other thing we need to do is we need to get this negative. What we do is we factor it out, but not really out. We factor it out of the x. Okay. So I factored it out of the inside quantity, yes? So it's separate. So this negative inside the parentheses reflects it over what axis?
The X.
Y.
The y. The x would be in the front, wouldn't it?
Yeah.
So it's reflecting over the x. So first of all, my brain, it went like this, yes?
Yes.
Yes. So now it's going to go down like that.
Just gonna-
But it's also going to do what else? So it's reflecting over the x.
Thought it was over the Y.
I mean the y. Sorry. Oh, yes, and I did it over the x. Thank you very much. I should have written it, then my brain wouldn't have messed it up. Okay, so let me write it down so I don't. Reflect over y-axis, right? So instead of going like this, it's going to go which way? This way?
I can't explain.
That way?
Yes.
Instead of going right, it's going to go what? Left?
That is left.
And then what is this going to do to it?
That's
Go
going to
move it.
move it to the left.
Right.
three.
Right
Right.
3. Because we factored out the negative.
Oh yeah.
We now have a
Y.
So it's going to go this way 3. So 1, 2, 3. Oh, wait, I did that wrong. Has to move this 3, yes? So 1, 2, 3 would be at where? 2? Because we were here, weren't we?
Yeah.
And if I move this 3 to the right, it would be 0, 1, 2. Okay? So I was right. My asymptote will be at 3, but the graph goes. Now, do these make our brains really stretch and think? Yes. And it almost looks like a reflected exponential graph, doesn't it?
Yeah.
Kinda. We could get it there. Okay, so it went left. It went left, but reflected. So, oh my gosh. So 0, 1 ultimately went, nope. 1, 0 ultimately went to where?
Negative
Two.
1, 0.
It went to negative 1, 0, and then it went
Because it links us.
to what?
Two.
2, 0. Because we had to do more than one transformation, didn't we?
Yeah.
Now what is the domain? Because the domain was 0 to positive infinity.
Now it's negative infinity to 3.
Now it's negative infinity to 3. When somebody asks me to describe the change on something like this, I always have to sketch it because there's a lot of, when we reflect over that y-axis, does it mess with our brain a little bit? Especially when we reflect it over the y and move it left or right. That does mess with your brain. Anything else change? Range going to change?
The range will not change.
Nope.
Why does domain change like that?
Because
This is looking-
it's reflected over the y-axis, so instead of going to the right, it's going to the
Oh.
left.
Okay.
Vertical asymptote went from where?
It went from-
X equals 0 to
3.
x equal 3.